So, welcome back to class, guys. Yeah. So, today we'll be talking about quadratic equation. That's the topic for today. Yeah. So, this is quadratic equation part two. We did, I think, quadratic equation the part one. I think the last 3 weeks, right? So today is going to be the part two, and I'm very sure this is going to be an interesting class. You guys should stay put, stay online. Yeah, any question you have, you can just write it on the chat below. Yeah. So yeah.
Yes, so we begin now. So if you're in the class and you can hear me, just type one. If you can hear me clearly, type one so that we are all on the same page. If you can hear me clearly, type one. If you can hear me clearly, type one. Yeah, if you can hear me clearly, type one. And then share the link so that others can join, so that they don't draw us back when we let them join at this beginning. So if you can hear me, type one. Okay, no, Divine, not that one. Okay. If you can hear me clearly, type one so that we can begin. Today we're looking at quadratic functions, and it's going to be an interesting one. So if you can hear me clearly, type one. Okay, anyone's in the house? If you can hear me, type one. Can you hear me? Okay, should we still wait for others or we begin? Okay, so let's give a few minutes, say 3 to 4 minutes. So let's invite others in so that we can just go fully with the class. So while waiting for you, share the link to others. Let's join up and begin. Okay, yeah, this is El Sam. Today we're going to be treating quadratic functions. So let's go. Now, first, before we talk about quadratic functions, let's know what quadratic equations are. Now, what's a quadratic equation? It is an equation that looks like this. Now, A, B, and C are constants. So A is not equal to 0. Yeah. Before we look at quadratic functions, we need to understand what quadratic equations are. So a quadratic equation is an equation that looks like this. It's a polynomial of degree 2. Okay. Now the next question will be, we've treated this in our last life already. Now, how do we solve a quadratic equation? We can use factorization. We can use completing the square. We can use formula, and we can use graphs. So these are 4 ways that we can solve quadratic equations. Now, the next thing will now be, how do we form a quadratic equation? Okay, another thing is that when you solve a quadratic equation, you would have 2 answers. The answers might be equal, might be distinct, and might be complex, but you have 2 of them. Now, those answers are called roots of the equation. So the one you solve a quadratic equation, what you get is the roots of that equation. So the first root, generally we'll call it alpha. Okay, so where A, B, and C are constants, this quadratic equation of these methods: factorization, completing the square, formula, or graphical method. And now we're talking about the roots of an equation, alpha and beta. Those are the 2 answers when you solve a quadratic equation. And those roots can be complex, can be equal, can be distinct. Yeah, so we'll look at all of that. Now, if the roots of a quadratic equation are given, we can form the equation from the given roots. And how do we do that? We use this formula. We use this formula. So the formula says x squared minus sum of roots, like those 2 answers we call roots. If you add them together, the sum of the roots, x plus product of roots, equal to 0. So with this formula, we can form a quadratic equation when the roots are given. Okay. Now, 2 more things before we start solving problems. One is sum of roots. Now, if you add the two roots of the quadratic equation, that is equal to, from the original equation, minus b over a. Remember, a is the coefficient of x squared, b is the coefficient of x, and c is that constant. So sum of roots of a quadratic equation is given as minus b over a. And then product All right, yeah, welcome back. So before the bad network, we solved question one, which says 5 is one of the roots of this equation. So we solved question one. Now I wanted you to solve question three, but now let's do it together. So question 3 says minus 5 is a root of this quadratic equation, which is, that's question 3 now, which is n squared minus 8n minus 65 equal to 0. Okay, so the two roots are minus 5 and let's just call it x. So let's say minus 5 and x are the roots of this equation. So now we have to look for that x. It says what is the other root? Since they give minus 5 as 1, what is the other root? Now remember what we did earlier. We said that sum of roots equals to minus b over a. What's our a in this case? Our a is the coefficient of n squared, which is 1. And what's our b? Our b is minus 8. Okay, so sum of roots, that's minus 5 plus the other root x equals to this sum of roots here will give us what? Minus b, which is minus 8. Our b is minus 8, right? Over a. Our a is 1. So from here we'll have minus 5 plus x equals to what? 8. Positive minus times minus is positive. So x will be equal to 8. This minus 5 coming here becomes plus 5, right? So an x equals to 13. So our x is equal to 13. So that's the answer for question 3. That's question 3. Now, and let's look at question 2. Question 2 says 7 and minus 3 are roots of this equation. Find k. Now, I gave you a formula that you can use to form the equation from the given roots, right? Okay, so let me rub this. So we're given the two roots. So the first root is 7 and the second root is minus 3. We're solving question 2 now. Remember we said that the sum of roots and product of roots can be used to form the equation. So for any quadratic equation, x squared minus alpha plus beta, that's the sum of the roots, x, plus the product equal to 0. So we said this earlier. So now applying this, since we have our alpha and beta, we can apply all of this into the equation and then we get our equation. So let's do that. So the equation will be x squared minus the sum of roots. We have 7 plus minus 3, right? As sum of roots, x plus product of roots. We have 7 multiplied by minus 3 equal to 0. So we have x squared minus 4x, right? That's 7 minus 3, that's 4. And this minus will affect this to become minus 3 times 7, 21, equal to 0. So this is the real equation whose roots are 7 and minus 3. Now, coming back to what we were given this x squared plus kx minus 21 equals 0. Now, since we are to look for k, and this is the right equation, obviously, our k equals to what? Minus 4. Minus 4 is the coefficient of x, So k is the coefficient of x. So k is equal to -4. And that's it. So we've solved questions 1, 2, and 3. Now, for question 4, I will allow you to solve question 4 because I believe question 4 is very easy and straightforward. It says, find the sum and product of the roots of this equation. So the sum of the roots of the equation and then the product of the roots of the equation. So you have to look for the sum and the product for number 1, the sum and product for number 2, the sum and product for number 3. So okay, for the sake of those that did not come from the beginning of the class, I will quickly do number 1, and then you can use the idea to do numbers 2 and 3. So for number 1, as number 4i, we have x squared plus 5x plus 6 equal to 0. Now we need to find the sum of roots. So sum of roots equals to minus b over a, while product of roots equals to c over a. But first, what's our a in this case? A is what? 1, b is what? 5, and c is what? 6. So sum of roots will be minus, what's our b? 5. That's minus b, which is 5, over a, which is 1. And on one side is minus 5. Product of roots is c over a. What's our c? 6 over a, 1. And our answer is 6. So it's as straightforward as that. So sum of roots minus b over a, we have minus 5. Yeah, and product of roots is 6. So the II now, which is x squared minus 6x plus 8 equals 0. So find the sum of roots. Also find the product of roots. Okay, and for number 3 also, you have to find the sum of roots and the product of roots. Okay, so I'll give you 60 seconds each to do numbers 2 and 3, and then we'll do it together based on your answers. So just comment your answer. So for number 2, sum of roots is this, product of roots is this. So put your answers in the comment section. I'll be watching for it, and then in 2 minutes time, we'll continue. Okay, so bear with us for the break in transmission. We're back. Okay, so in this first case, okay, let me give you a few seconds to get back to what we were doing. So if you're back or you can hear me now, just type 1. If you can hear me clearly, type 1. Let me be sure that you're following so that we continue. If you can hear me clearly, type 1. In the comment section, type 1. Okay, so yeah, some of you can hear me. Let's go on. So sum of roots is what? Minus b over a, which is minus, our b is minus 6 over a is 1, so which is 6. Product of roots equals to c over a, right? So what's our c? 8 over a 1, which is 8. So Karim Blessing, I think you're correct. Yeah, from what you got earlier, you're correct. Okay. Now, for this last one, our a is 2, our b is minus 8, and our c is 5. So the first one, sum of roots equals to minus b over a, which is minus b is minus 8 over a is 2. So minus multiplied by minus is positive. So you have positive 8 over 2, which is 4. I think, Blessing, you're also correct. So let's see the product of roots. That's c over a, right? So what's our c? Our value for c is 5. And our value for a is 2, which is 5 over 2. Okay, so I believe by this we've understood the concept of sum of roots and product of roots. Now we're going to use all of the idea we've gathered now to solve real problems. So this number 5 here will be our like a number 1 for the real deal. So it says if alpha and beta, if alpha and beta are the roots of the equation, find the quadratic equation whose roots are 1, 2, and I think I'll add my own 3 to it. So let me rub this quickly and then we proceed. Okay, so we have a new equation that says x squared minus 5x plus 6 equal 0. Now the question says, can you zoom? It's number 5. The question says that if alpha and beta are the roots of this equation, which I've just put up there, find the quadratic equation whose roots are alpha over beta plus beta over alpha. And before we proceed, let's establish what we already did earlier. Again, now the sum of roots first for this alpha plus beta equals to what? Minus b over a, right? So which is minus 5 over 1, which is 5. So alpha plus beta is 5 based on the equation we have. Now, alpha, beta, product of roots is C over A, right? And that is C, which is 6 over A 1, which is 6. So now the first challenge is that we are going to find a new quadratic equation whose roots are alpha over beta and beta over alpha. Okay, so now we have alpha over beta and beta over alpha. Now remember that to form a new quadratic equation, you need the sum of the roots and the product of the roots. So let's look for the sum of the roots. So sum, that's alpha over beta plus beta over alpha. What would that give us? Remember, when adding fractions, you use LCM, right? So what's the LCM of alpha and beta? That's alpha beta. Beta in alpha beta gives you alpha. Now alpha times alpha, that's alpha squared, plus alpha in alpha beta, that gives you beta, right? Beta times beta, that's beta squared. Okay? So alpha square plus beta square is equivalent to alpha plus beta square minus 2 alpha beta all over alpha beta. Okay, but don't take my word for it. Let me just show you why this is this. Let me show you quickly. Let me do it quickly so that I'll rub it off because we'll need all of that. Now, know that if you have, let's say, alpha plus beta square, if you expand this, it will give you alpha square, right? Plus, if you multiply alpha, beta, and 2, you have 2 alpha beta, right? Plus beta square, isn't it? Now, if this 2 alpha beta in the middle, if you bring it to this other side, you have alpha plus beta square. This becomes minus 2 alpha beta, right? Equal to, then what you have left here is the alpha square and beta square, right? Plus beta square, right? So that's what we just did, that alpha square plus beta square is the same thing as alpha plus beta square minus 2 alpha beta minus 2 alpha beta. Now, we'll save this one. What if it was negative? Okay, we are not likely to need the negative one. So I'm just trying to show you how we got this. Okay, so fortunately, we already have alpha plus beta here, right? So this will give us alpha plus beta itself is 5, right? So 5 square minus 2. We have alpha beta, which is what? 6. All over alpha beta, which is 6. So what we have now is 25 minus 12 over 6. So 25 minus 12, that will be what? 13 over 6. So that's our new sum. Remember that we need sum and products to form that new equation. So let's look for the product. So we'll have what? Alpha over beta times beta over alpha. And that's 1 because alpha here 1, beta here 1. So our final answer is 1. So the new equation we want to form will be x squared minus alpha plus beta, that's sum of roots x plus product of roots equal to 0. That's, we mean sum, we mean product. So our answer will now be x squared minus our new sum is 13 over 6 x plus our new product is 1 equal to 0. Now, because we have a denominator here, we can multiply throughout by that denominator. If we have more than one denominator, so we multiply through by the LCM of all the denominators. So here we have only 1, 6, so we'll multiply throughout by 6. So multiply throughout by 6, so we'll have 6x squared minus that 6, we cancel this 6 down, so minus 13x plus 6 times 1, 6 equal to 6 times 0, 0. Okay, so this is the new equation whose roots are alpha over beta and beta over alpha. So lengthy but interesting. Now, based on what we have, as you still solve up to this point, now from here down, you change your alpha, you change this to alpha plus 2 and beta plus 2, and then you solve. So based on this equation, whose sum of roots we already know and product of roots we already know, find a new one whose roots are alpha plus 2 and beta plus 2. I don't know if I can rub this so that you have clarity. Okay, so just bear in mind that we have solved number 1. So you have to solve number 2 now. Alpha plus 2 and beta plus 2. So you want to give us the equation like this, whose roots are alpha plus 2 and beta plus 2. Remember that you already have the sum of roots, the alpha plus beta and the alpha beta. So if you can do this, find your sum first. It will give you some values for which you will get the real value. You also find the products, and then you have an answer. So let me give you 60 seconds only. Okay, Newton's formula. Okay, you don't need Newton's formula. Somebody just asked where you have to use Newton's formula. So you don't need Newton's formula actually to solve this. So if you follow this sum of roots and product of roots, you'll be able to get your answer. So let me leave this one here, but you have to solve for this. So I'll leave what I've done here to guide you to quickly do yours. And in 60 seconds time, we'll continue. So see you soon. So we're looking for these two roots, a new equation whose roots are alpha plus 2 and beta plus 2. So first, let's look for sum. So we have alpha plus 2 plus beta plus 2. So if we do this, we have alpha plus beta plus 4. That's 2 and 2 is 4, right? Now we already know alpha plus beta as 5, right? So we have alpha plus beta 5 plus 4, which is 9. Products. Alpha beta, which is alpha plus 2 times beta plus 2. So if we multiply these two, we'll have, remember, FOIL, first, outer, inner, last. Okay, hope I'm not blocking. Okay, so first will give us alpha beta plus 2 alpha plus 2 beta plus 4. So if we rearrange this, we have alpha beta plus 2 alpha plus beta plus 4, right? Yes, factorizing that 2 from the alpha and the beta. So that's good. So alpha beta from here is 6 plus 2 into alpha plus beta is 5 plus 4. So we have 6 plus 10 plus 4, which will give us 20. Okay, so our equation will now be x squared minus sum of roots x plus pro of roots equal to 0. So we have x squared minus sum of roots is 9, minus 9x plus product of roots 20 equal to 0. And that's the answer to this. Now I want to give you one last one to do. So find a new equation from this equation, but the roots of that new equation are 1 over alpha and 1 over beta. So you are solving number 3 now. 1 over alpha and 1 over beta. So we've solved this already. We just solved this now. This is our new equation. Now you want to solve this and give us another equation. So let's go. I'll give you 60 seconds only to just try it out. You see, mathematics, you learn mathematics by doing. So no matter how much you watch me teach, if you do not practice it, you have not understood it well. So try to do this quickly and then we'll proceed. Okay, so when I want to solve this, okay, so sum, we have 1 over alpha plus 1 over beta. What's our LCM? Alpha, beta. Alpha and alpha, beta, that's beta. So alpha and alpha, beta, beta, beta times 1 is beta, plus beta in alpha, beta is alpha. Alpha times 1 is alpha. So what we have is alpha plus beta over alpha, beta. Alpha plus beta, we already have that as 5. Alpha, beta, we have that as 6. Product, 1 over alpha multiplied by 1 over beta, that's 1 over alpha, beta. 1 over, what's alpha, beta? We have alpha, beta as 6. Okay, so sum and product clear. Remember our formula, it says x squared minus sum x plus product equal to 0. So we have x squared minus, what's the sum of the roots? 5 over 6x plus what's the product? 1 over 6 equal to 0. Now, the LCM of all the denominators is 6. So we can multiply throughout by 6. And then if we do that, we have 6 times x, okay, you have 6x squared minus 6 will cancel 6, we have 5x plus 6 will cancel 6, you have 1 equal to 0. Okay, so that's the answer to this interesting one. So before we go, we'll solve one more. But this one might appear a bit more complex, but I believe you can do it based on what we've done. So let me give you the question quickly. So question says, so whose roots are 1 over alpha plus 1 and 1 over beta plus 1. Okay, so based on what we've learned so far, I want you to run through this quickly and give me your answer. So I'll give you 90 seconds and then we'll solve it together if you can't, but I believe you will because we've done enough examples. So your time starts now. Let's go. Okay, so let me solve it over here. Okay, so we have this quadratic equation. But now we have to find a new quadratic equation whose roots are these. Because this one, the roots are alpha and beta. So let's go. So we have 3x squared minus 10x plus 8 equal to 0. Let's begin. First, our A is 3, B is -10, and C is 8. So that one established. So based on this, our sum of roots alpha plus beta from the original equation is what? Minus b over a, which is minus b, which is minus 10 over 3. So minus minus gives us positive 10 over 3. Now, what about product of roots? Alpha, beta, the product of these roots will be c over a. And our c is what? 8 over 3a. So we have both. Now here comes the question. We have to find a new equation whose roots are 1 over alpha plus 1 and 1 over beta plus 1. So let's look for the sum in this new case. So 1 over alpha plus 1 over beta plus 1 equals to, first we'll start with the LCM, right? The LCM will be alpha plus 1 multiplied by beta plus 1. Alpha plus 1 and alpha plus 1 cancels. You have beta plus 1 left. So beta plus 1 times 1, that's still beta plus 1. Plus, in this case, these two cancels. You have alpha plus 1 left. Alpha plus 1 times 1, that's alpha plus 1. Now, if you look at that numerator very well, what you have is alpha plus beta plus 2. Like alpha plus beta plus 2. Now, if you look at the denominator very well, let's expand. Remember our FOIL, first, outer, inner, and last. So first will give us alpha, beta. Outer will give us plus alpha. Inner will give us plus beta. Plus last and last will give us 1. So what we have here is alpha plus beta, which we know, plus 2 over alpha beta, which we know, plus alpha plus beta, which we also know, plus 1. So let's put the parameters in it. So we have alpha plus beta is 10 over 3 plus 2 over alpha beta is 8 over 3 plus alpha plus beta 10 over 3 plus 1. Okay, for the numerator, we'll have over 1, 3. 3 in 3, 1, 1 times 10, 10 plus 1 in 3, 3, 3 times 2, 6. So the numerator will give us 16 over 3. That's for the numerator. A denominator will give us LCM again of 3. 8 plus 10 plus 1 in 3, 3, 3 times 1, 3. That gives us 21 over 3, which is 7. So if we put them together, numerator over, this is the denominator. So let's bring it here. So numerator 16 over 3 divided by denominator 7, or we can change this to multiply by 1 over 7. So that gives us 16 over 21. So this is our real sum. Okay, so products will give us 1 over alpha plus 1 multiplied by 1 over beta plus 1. So 1 multiplied by 1 is 1 over, if we multiply this to, we have alpha plus 1 beta plus 1. So we already have the product here. The product is this, right? Which is also this, which is also 7. So we have 1 over 7. The product is 7. Yes, so to round it up, remember our equation is x squared minus sum x plus product equal to 0. So we have x squared minus, what's the sum? 16 over 21 x plus product 1 over 7 equal to 0. So the LCM of 21 and 7, which are the denominators, is 21. So multiply throughout by 21. So we'll have 21x squared minus 21 into 16 over 21x plus 21 into 1 over 7 equals to 21 times 0. And our final answer will be 21x squared minus 16x plus 3 equal to 0. And that's our answer. Okay, so kindly subscribe to this channel so that you can keep getting notified when we post videos, and then you can get interesting solutions to mathematical problems. My name remains Samm. So subscribe now, like the videos we have, and then it's going to be an awesome time next week, 5 p.m. So join us 5 p.m. West African time, Friday. Don't forget to subscribe to this channel so you can keep getting interesting solutions to mathematical problems. Thank you. Just
So thank you for joining, guys. I know it's a very long class. I'm not gonna lie. So yeah, I hope you enjoyed the class. I hope you understood everything we talked about. I mean, we talked about quadratic equations today. So thank you guys for joining. I hope you guys have already subscribed. There's a red icon or button below. Just tap subscribe and you'll be notified. Like every videos where we're going to drop, you are going to be notified. Yeah. So follow us next Friday by 5 p.m. We'll be holding this same class but different topic. Yeah. Next week Friday by 5 p.m. West African time. So I want to see you guys there. Yeah, I remain Devian. What else? I think that's it, right? Yeah. So a quick one before you guys leave the live session. So like this upcoming Friday, or rather Wednesday rather, we are going to be having just a little live session. Yeah, we are going to be treating complex numbers. Yeah, so it's going to be the same time, 5 p.m. So yeah, on Wednesday by 5 p.m. we are going to be treating complex numbers. So I think we are going to make it okay, every Wednesday, right? Every Wednesday we are going to be having live session Wednesdays and Friday 5 p.m. So you guys should take notes. Thank you.